Okay, in this class, we will see about the classification performance. Classification means it's a kind of a supervised learning algorithm. We know that regression, classification, these two are the different kinds of supervised classification, supervised learning algorithm. In the supervised learning algorithm, first one is the regression. In the regression, how do you find that performance, mean square error, root mean square error, R square error? These are some of the techniques used to find the performance of the regression. Similarly, for the classification, we use some measures for identifying the classification performance. The commonly used performance are, first is, we should know what is classification. It's one of the most common tasks in the machine learning. In the classifier, it maps the given data into a different classes. Suppose there are classes from C1 to CK, the entire data is mapped into different classes based on the class labels. For that, we use the training as well as the testing. Training is used to develop the model, and next testing is used to identify whether the developed model is correct or not. First one is the learning. Learning is otherwise called as the training. The classification algorithm first train the data. With the help of that, we will generate the classification rule. Then with the help of the classification rule, we will test the data. That's the general concept used in the classifiers. So the classification, developed classification rules are used to check the data, whether this is correct or not. The most important measure of the classification is the classification accuracy. The classification accuracy of a classifier gives the percentage of the test set tuples that are correctly classified. Accuracy means it gives how much correctly the classifier rule classify the given data. That is called as accuracy. Okay, accuracy means how correctly the data is classified by using the developed classifier. Now we are considering only the binary classification. In our class, we will discuss only about the binary classification. You know that binary classification means the classifier contains two outputs. One is 0 and 1. Two cases of outputs, true or false, yes or no, 0 or 1. Only two types of outputs are there. Two types of labels are used in the binary classification. To find this accuracy, first you need to develop the confusion matrix or else the contingency table. The contingency table or the confusion matrix can be developed for each and every classifier. The confusion matrix gives the details about the classifier, how it classifies the data. It gives the details about the classifier, how it classifies the data. Example, consider this one. This is one example for this confusion matrix. Here, actual values are there and the predicted values are there. Only two classes, positive class as well as the negative class. The positive and negative are the two classes considered here. Here, actual positive values are 30 and predicted positive values are also 30. 30 values are actually positive and that is also predicted as positive. Then this is called as true positive. Okay, positive values that is predicted as positive itself is called as the true positive. It's not necessary that all the classes are predicted as the same. Sometimes there is a deviation also. We are going to find how much the classifier is deviated for the output. So actually positive and the values are positive and that is also predicted as positive means that is called as true positive. In this contingency matrix or confusion matrix, the true positive value, true positive equal to 30. Okay, so this is the true positive value. The next one is actually negative values. Actually negative values, that negative values are predicted as also negative. Actually also negative, predicted also negative. That is called as the true negative. Actually, that is the negative value. That is also predicted as negative. That kind of values are called as the true negative. So here the true negative equal to 40. First, you should know about the true positive as well as the true negative. Positive values, actually positive values. By the classifier also, it is classified as positive value. That is called as the true positive. Actual means that's the value available in the data set. Predicted means the value predicted by the developed classifier. If both are positive, that is true positive. If both are negative, that is the true negative value. Again, two more terms are used here: false positive as well as false negative. False positive and false negative. Actually, the values are negative. Actually, these values are negative, but the classifier predicted that as positive. Okay, actually the values are negative, actual negative values. False manner, the classifier predicted that as the positive. That is called as the false positive. Okay, false positive means actually these are the negative values, but the classifier classified that as the positive values. In false manner, it classified that as a positive values. That set of values are called as the false positives. Same manner, false negatives. Here 10 is the false positive. Actually, this is negative, but the classifier predicted this is the positive. Wrong manner. False manner, it's predicted as positive. False manner is predicted as positive means that is called as false positive. Same manner, false negative. What is false negative? Actually, that is the positive value. False negative. False manner, it's treated as negative. Actually, this is the positive value, but the classifier predicted that as the negative value. That is the false negative. False negative means falsely it's classified as negative. Actual positive that is classified as negative is called as false negative. So in the confusion matrix, there are four things. What are the things? First one is true positive, then true negative, false positive, and false negative. True positive means the positive values that is actually positive values in the data set, and that is also predicted as positive by the classifier. Then it's called as true positive. True negative means actually that is a negative value in the classifier, or that no value in the classifier, and that no value in the data set. Classifier also predicted that is the negative value, that is the true negative. True negative is classified as negative, positive is classified as positive. That is true positive and true negative. False positive means actually the value is the negative, but the classifier predicted that as the positive. That is what called as the false positive. Same manner, false negative means that is actually the positive value. The classifier classified as the negative value. That is what called as the false negative values. So in this example, 30 is true positive. You see here, this 30 is the true positive, and this 40 is the true negative, and this is actually negative but predicted as positive. This is false positive, 10 is the false positive, and 20 is the false negative. These are the values used to find the accuracy, precision, recall, everything. The classification performance are calculated from these terms only. So actual values and predicted values. Actual value is positive and predicted value is also positive. Then that is true positive. Actual value is positive and it's predicted as negative means false negative. Actual value is negative, that is predicted as negative means that is true negative. Actual value is negative, but it is predicted as positive means false positive. This is the confusion matrix. What are the terms given in the confusion matrix? True positive, true negative, false positive, and false negative. The false positive is otherwise called as type 1 error. In the classifier, type 1 error means that is the measure of the false positive. Same manner, false negative is called as the measure of false negative is called as type 2 error. In the classifier, the false negative terms, now false negative values are called as type 2 error. Okay. Then these are the formulas used to find the accuracy, precision, recall, everything. Accuracy can be calculated. Accuracy represents the number of correctly classified data instances over the total. Among the total data, how much is classified correctly? That is given by the accuracy. Consider this is the confusion matrix. We know that this is the true positive value. This one is the false positive value. This is true negative. true negative, and this one is the false negative value. The values are given means the accuracy can be calculated by using the formula that denominator contains all the values. What is the all the values means? This value plus this value, this value, this value. All the entire data values comes under the denominator. So the entire data is true positive plus true negative plus false positive plus false negative. Take all the values in the denominator, and the numerator is what are the values that is correctly classified. Correctly classified means true positive values as well as the true negative values. Okay, take the values that are correctly classified. So here I have taken the value that are correctly classified, 45 plus 30, that is correct. Another things are falsely calculated. So I am taking these two values, 45 plus 30. 45 plus 30 divided by the entire value, you will get the accuracy. Here the accuracy is 75%. 0.75. You can write this as 0.75. 75% means it's better, but not it's good only. The classifier is good only, not the best one. If it is best classifier or for the ideal classifier, the classifier is a good one that is classifying everything in the correct manner means what will be the accuracy? The accuracy equal to 100%. Everything can be calculated correctly. Every data point is classified correctly means that's called as the ideal classifier. For the ideal classifier, accuracy equal to 100%. The next one is the sensitivity. Sensitivity referred as true positive rate or recall. The other name for that sensitivity is the recall. True positive rate. True positive rates, how much values are positively predicted correctly. Totally, the recall or sensitivity can be calculated by using the formula true positive divided by true positive plus false negative. Among the data set, some values are calculated as generally positive values, and some values, unfortunately, it comes under false negative. Positive values are classified as negative. That's actually the positive value. That's classified wrongly. So here the recall or sensitivity can be calculated out of all positive classes, how much we predicted correctly. Here true positive is 45 values predicted correctly, but total correct values are this 45 plus 20. Here it's 69.23 or 0.6923. This is the sensitivity. Sensitivity means how the positive classes are classified. Similarly, next is the specificity. Specificity means how the negative values are classified. That is yes. How yes is classified means that is sensitivity. How no is classified means that is specificity. Totally some negative values are there. How much values are classified correctly? The values correctly classified as negative is 30 divided by total negative values is true negative plus false positive. That is equal to 30 divided by 30 plus 5 equal to 85.71. This is the specificity value. First one is accuracy, totally how much it's classified correctly. Then sensitivity, among the positive value, how much is classified correctly. Then next one is specificity, among the negative values, how much is classified correctly. That is the specificity. And next is the precision. Precision can be calculated by using the formula true positive divided by false positive plus true positive. This is the precision value. All must be high. If sensitivity, specificity, accuracy, precision, all will be high for the good classifier. Or for the ideal classifier, all the values must be 100% or 1. The next one is the F score or the F1 score or the F measure. That will give how precision, that is it provides a single score that balancing as the precision and recall, that balancing the sensitivity as well as the specificity. Actually for the medical data set and all, we are calculating the sensitivity and specificity only. This is the formula used to calculate the F measure, 2 into recall into precision divided by recall plus precision. This is used to find the F score. Now you know what is accuracy, what is sensitivity, what is specificity. Sensitivity is otherwise called as recall and F measure. The next is the These are the evaluation measures. And another one important thing is the area under curve. Area under curve is used ROC curve. Similar to the lift charts, this area under curve here, area under curve can be drawn with respect to false positive rate and true positive rate. If the area under the curve is high, means the performance of the classifier is also high. The area under the curve is high. ROC curve or the area under the curve is high means it's always above this level, and if it is high, then the performance of the classifier is good. That's all about the performances. Now I'll give one problem. For that one, you find the sensitivity, specificity, accuracy, recall, precision, everything. Solve that.